Welcome to this slide presentation introducing NuclearSafetySim, a training and development tool for nuclear safety professionals. This presentation describes important aspects of the approach and modeling used in NuclearSafetySim. We strongly encourage you to review these materials prior to further exploring the use of the SIM on this website. NuclearSafetySim arose out of our view that the decision-making environment for nuclear operations is very challenging and current training methods do not adequately prepare individuals or teams to make the best possible decisions. Our approach utilizes a computer simulation to allow personnel to practice making decisions that appropriately balance safety implications with other organizational needs. We believe this is the essence of safety culture. This is the home screen of NuclearSafetySim. On our website you can view a demo of the SIM and access a prototype version to play the SIM. Clearly, NuclearSafetySim is a new approach to safety culture training, specifically directed at decision-making skills. Nuclear plant licensed operators have long used plant simulators to practice their skills in manipulating controls and implementing appropriate procedures. NuclearSafetySim is a management simulator, sometimes referred to as a game, because it creates a quasi-realistic environment within which a user can interact and experience decision-making challenges and outcomes. More specifically, it is a category known as serious games, where the objective of the SIM is outside of the context of the game itself. In this case, the SIM fosters a way of thinking, not just a set of practices, and tracks and aggregates user interactions for analysis of behaviors and motivations. Ultimately, we believe this kind of activity fosters awareness of how decisions interact with and come to exemplify safety culture. Let's take a look at the conceptual approach taken in the SIM. Simulations embody models of real situations. Such models are inherently simplified versions of reality, but the objective is to capture the essential aspects and dynamics associated with a nuclear management system. In essence, NuclearSafetySim is a hybrid model consisting of two parts. One part is a simplified representation of nuclear operations in three dimensions: plant generation, budget, and safety. The other part is a decision-making module. Note the reciprocal relationship between nuclear operations and performance, and the layers of culture and other factors through which these interactions occur. We'll see how these two parts work together in a few minutes. Decisions are the key focus within the SIM, reflecting their pervasiveness and their obvious importance to achieving all of the organization's goals, including safety. Decisions provide the clearest expression of the organization's culture and commitment to safety. In NuclearSafetySim, we provide the ability to examine the whats and whys of decisions, not just their outcomes. As we said earlier, nuclear management decision-making is very complex, involving multiple dimensions and inherent fuzziness or uncertainty in the judgments that are involved. We are most concerned with issues that arise that have safety implications. Much of safety culture and safety regulation require judgments to be made regarding the safety significance of an issue. The reality is, such judgments can legitimately vary and inherently involve uncertainties. So at the outset, decision makers are confronted with a situation which is shades of gray. What to do in response to a given issue, the decision itself, includes its own dimensions of fuzziness. How effective will a course of action be in addressing the issue? And what will be the impacts on other aspects of performance, such as plant generation and budgets? Some decision options offer greater effectiveness, but perhaps at greater cost. Other decision options may be marginally effective or be extremely conservative. Regulatory requirements also bring with them a need for judgment and interpretation. Cutting through all of these overlapping considerations are the other non-safety performance goals for the organization and its personnel. Sometimes these are the elephants in the room when decisions are being made, and ironically, they often present the clearest choices. As we indicated earlier, the sim uses a hybrid approach. For operations, the sim player must manage safety, plant, and organizational performance through their proxies of corrective action backlog, capacity factor, and budget. The key performance levers are resources, both total resources and how they are allocated to the three priorities, and resolving problems that arise during the sim. We fully recognize that this representation does not capture every complexity and nuance of the real environment. We have developed and used sims with more sophisticated modeling of nuclear operations in an analytical context. For a player-based interactive sim, it is better to start with a fairly simple model to minimize the learning curve. As a player's facility with the sim increases, it is possible to introduce more complexity and increased learning opportunities. As illustrated on this slide, resources and problems become the primary working fluids in the simulation. Note the system view of the relationship between the variables and the continuous nature of feedbacks. Note the impacts of decisions, the other piece of the hybrid model. Decisions perturb the system, and the system returns the complement by pressuring future decisions. The sim incorporates realistic issues taken from actual plant experiences to challenge the decision-making skills of the player. Issues arise periodically and include a number of decision options to address the underlying problem. Here's the description for one of the issues in the sim. It involves work on an energized DC power panel while the plant is at power. The description describes the plant state and the specific conditions leading up to a decision. Up to 4 decision options are provided, and each describes the potential impacts on capacity factor, cost, and corrective action problems. Note that in some cases the impacts are probabilistic and/or occur with a time delay. The impacts are specified in order to ensure that each player is basing decisions on the same information. A more advanced version of the sim would have players input their assumptions regarding impacts as part of the decision analysis. As part of the decision-making process, the player is asked to assess the issue and assign values for its safety significance and the uncertainty associated with that significance. The values are based on anchored scales, which we'll cover in subsequent slides. Generally, the decision options reflect a spectrum of conservatism and varying potential impacts on performance, much as real decisions do. And the options do not present right or wrong decisions. Rather, they offer greater or less conservatism, effectiveness, and impacts, as we illustrated in the bubble diagram slide. An additional factor is compiled for each decision option. The balance score indicates how strongly and accurately safety factors into the decision selection, consistent with the objective that safety receive priority, commensurate with the overarching objective of assuring safe and reliable operations. The balance scores and the preferred decisions are pre-assigned in the sim based on input from the management team. The scores are not visible to the sim player during the sim. However, they are displayed in the results section at the end of the sim and can be used to interpret the player's decision process. This slide shows the anchored scale for decision balance. The scale sets a 0 value as the measure of an optimal balance of safety, meaning that it meets the expectation of the NRC's safety culture policy statement to give the priority warranted by safety significance. Increasing positive values are associated with decisions that accord extra weight to safety. Increasing negative values accord less weight. These are the anchored scales for safety significance and uncertainty. The significance scale is generally consistent with the NRC's significance determination process. Another aspect of decisions is the context in which they are made. Safety significance is one major consideration. Always present, in addition, is the ongoing performance of the nuclear organization. Going back to the conceptual approach for the SIM, we use the three components to account for this: plant generation, budget, and CAP program performance. The SIM includes specified goals in each area and tracks performance against those goals during the SIM. We refer to the sum of the differences between actual performance and the three goals as goal pressure. Whether goal pressure actually has any effect on specific decisions, it may change the way decisions are perceived within the organization. The following slide illustrates how some of these parameters can be used to interpret the dynamics of decisions. Recall that we had referred to NuclearSafetySim as a serious game, meaning that its objective lies outside of the context of the game itself. In other words, playing the sim is really a way to capture data and analyze how the user interacts with the game conditions. This includes the explicit decisions in response to issues, decisions or non-decisions with regard to resources, the situational contexts, the timing, and several other parameters. In other words, both the what and the why of decisions. The chart on this slide shows plots of decision balance and goal pressure over the course of a sim run. Also shown is a plot of the preferred decision balance. Recall that our approach includes the ability for senior management to select preferred decisions for the set of issues in the sim. This provides a convenient benchmark against which to compare the actual decisions made by a sim player. A simple example would be, referring again to the chart, does a user's decisions respond to changes in goal pressure? NuclearSafetySim includes a rich data set which can be used to review and discuss the decisions made, the outcomes, and to compare to other players' results and/or established benchmarks. This slide illustrates the parallel decision analyses that are possible within the sim. A player's decisions can be enriched with contextual information and normalized against preferred decisions. These inputs may provide useful insights into the organization's safety culture. This schematic illustrates the multidimensional comparisons within the sim, player to preferred and player to player. Both tracks provide powerful learning experiences and team building opportunities. Thanks for viewing this introduction to NuclearSafetySim. We hope it feeds your interest in our approach and tools. We highly value any feedback that you can offer and look forward to hearing from you via the email link shown on the slide. Thanks again.